So the target tire pressure is 29 psi, and they said, what is this? The 24%. It's a warning if we're 24% below the target. So part A says, what's the psi that's going to trigger a warning? All we have to do is find out 24% less than 29. So that's like a 24% discount at the store, right? If you get 24% off, that means you're paying 76% of the product price. So that's my quick way of reducing a number by 24%. Multiply it by the complementary probability. In other words, take 100%, subtract 24%, and then multiply the decimal form to 29. Or you could just do it the old-fashioned way. Find out what 24% is, 6.96, and take that away. So same thing. 22.04 is that tire pressure. Oh, helpful, is it? This is black ink over here. I don't understand. I guess I'll try something else. It says I wrote in black ink. Oh, there we go. Okay. No, disappeared again. Okay, but you can see 22.04 is the tire pressure we're looking for here. I don't know why it disappears only in certain parts. Oops, okay, it's because I was hiding the correct answers. All right, so I guess I can't do that. I'll have to draw. So 22.04. Okay, so for the next part, they're saying, hey, now let's assume that it's normally distributed. So this is the stats part. 3 standard deviation, right? We'll need that for the z-score formula, because if we hear the word normal distribution, we should be usually thinking z-scores. Okay, so they say that, let's see, pressure's on target. What's the probability that it will trigger a warning? So they're saying the mean pressure for the population for these tires is on target. So I'm gonna plug in what that mean was up there, 29 in for the mean. And the standard deviation is 3. And they want the probability that we will trigger a warning. So the value that should go here is the warning value we just calculated, 22.04. So remember what z-scores are. You can take any number in a population, out of a population, and convert it to its z-score. And the z-score is just a helper to help us compute probabilities, basically. It can do other things too. It can help us compare values from different populations. But a big thing in stats is that you convert a value to a z-score, because then you can get a probability out of that z-score. So we wanted the probability that we're going to trigger a warning. That's why I put 22.04 in for x, because I want to convert the warning psi into a z-score. So we got negative 2.32. So what you'll want to do is go to Google and type in z-score to percentile calculator. We want to take a z-score, we want to convert it to a percentile or a probability. Either one is good. But what do we get? We got a z-score of negative 2.32. Click one-sided because we're asked the probability that they trigger this warning. So a warning would be anything less than that 22.04 value that we had, right? If you had a PSI of 22, if you had a PSI of 21, those would all trigger warnings. So that's why I clicked one-sided, and I want this left tail because I want the probability of anything less than that PSI. So that's a percentage of 1.02, and 1.02 as a decimal is 0.0102. Remember, if you're having trouble converting percentages to decimals, you just divide the percent by 100. And then part C, we're going to do the same type of thing, except now they want not a left tail. They want to know the probability that we're between these two values. So we're assuming that the mean of this population is 29 for these tires. We're doing everything right. We're filling them up at 29 at the start, and then they just lose air over time. So they want the probability that we are between these two values. And so what you'll want to do is convert each of these to a z-score. Then you can use that calculator I showed you. But we want to know this area, that we're within this range. Okay, let me see if I can type it a little easier. So the first one, 27, subtract that by the mean of 29, then divide it by the standard deviation of 3. So when you do that with your calculator, if you want, that should be negative 0.67. Or you could carry out some decimals. And then if I want to convert 31 to a z-score, 31 is the value I'm converting. 29 is that mean, the population mean that we're given. Standard deviation is 3. So this is 0.6667 in your calculator. Okay, and so what we're going to look up in that calculator is it only tells us, well, it could tell us areas between, but I think it has to be symmetrical. And this one is by coincidence. I'll show you how to do it in case they're not symmetrical. So this method I'll show you will work no matter what numbers you're given in your problem. But tables in the back of our book, calculators, they usually just give us the area to the left. So what I'm going to do is I'm going to look up in the calculator the area, the one-tailed area to the left of 0.31. And then I'll use the calculator to look up the area to the left of 27. I think I just said 1.01. The area to the left of 31. The area to the left of 27 is what I should have said. So because if you subtract the red area, the blue area from the red area, you're going to be left with that black area in the middle, right? So here, let's start with the red area, 0.6667 positive. The area to the left is 74.75 as a percentage. And they want probability, so I'm going to immediately convert that to its probability. Okay, that's the area to the left. And then for this one, negative 0.6 repeating. Just stick a negative sign on here. Sorry, it's early morning and I'm on baby duty. 25.249. 249, I think it was. Yeah, okay, so that's the blue area. And if we subtract those two, we'll have the area between. So there it is. 0.4950 is what I'd say for 4 decimal places. Let's see if that was the right answer. Oh, I cut it off. Okay. I'm pretty sure that's it. I'll continue the video if I did something wrong. So I used a bunch of decimals in a calculator. Your book, I think, is using the table values because the book got 0.4951. But I think if you're within 1/10,000th, you should be still marked correct. So this answer should, I think it'll still get marked correct.